Welcome to the channel, and my name is Manish Tiwari. So, up to day one in this Docker tutorial or the Docker playlist, what kind of concepts we have covered? We had covered about what is the Docker, why should we utilize the Docker, correct? So, we had talked about the real life scenario, the problem based on which this Docker has come into the picture. Why we have started learning the Docker itself, correct? So, this is what we have covered in day one of this playlist, the Docker playlist. And now moving forward, like after the comparison part, the problem part, how Docker will look like, correct? And what kind of attributes are there, like why your Docker is required. After that, now we are going to talk about the virtualization. So what is the use of virtualization? This is what we are going to talk about. Okay? So the Docker term itself is called as containerization, correct? But before containerization, getting into that, we need to understand this one. So virtualization means running multiple virtual computers on one physical machine. The first point, what I have written. Virtualization means running multiple virtual computers on one physical machine. So just suppose that you have this particular laptop. On this particular macOS laptop or Windows laptop, whatever you are utilizing, on that particular laptop itself, you are going to create multiple laptops. And it will not be a real laptop, it will be kind of virtual laptop. So just suppose that just considering one example that you have 16 GB of RAM for your laptop or 32 GB of RAM on your laptop, correct? So you are going to break this 32 GB of RAM into four pieces. So how number of RAM can be there for all these four pieces? 8 GB RAM for all these one components, correct? So you can break down your laptop into four virtual laptop with 8 GB RAM allocated to each and every one. So this kind of process, what you do, that is called as virtualization. You create four components, four parts, and those four parts will divide equally. Like it, the complete division will be based on how you separate, correct? How you segregate the resources for each and every VMs, correct? So just considering example, you are going to break down this 32 GB into four pieces, and that four pieces will be having 8 GB RAM to each and everyone allocated, and 2 core of CPU. If you have 8 core of CPU for your actual laptop, correct? So you are going to break down this 8 core of CPU into four parts. That will be 2 core CPU to each, and we will break down this 32 GB of RAM into four parts. That will be 8 GB RAM to each and every laptop. And all these four laptops will be kind of virtual on your real laptop. So that is the overall picture of your virtualization. How can you do? You have the different kind of tools that you can install on your system, and through that you can do. So one of the famous tool is hypervisor. So with the help of hypervisor, you can create the virtualization on your actual system. So just considering that I'm utilizing this Windows. So on this Windows, you can install the hypervisor and you can create virtual machines. Virtual system itself, virtual physical machines, correct? So what is the meaning of virtual machine or the virtual system or the virtual physical machine? What we are talking about? So when you are talking about all this, you are going to segregate the resource, you are going to create this, and you can have the different operating system for your each and every virtual machines. In short, we call it as a VM. Correct. So when I'm talking about that, it can be having the different operating system. What does that mean? That has simply mean that if I am utilizing this Windows operating system in real on this Windows laptop, I can create virtual machines of different operating system. That means if I am creating three different virtual machines on this particular laptop, what can I have? I can have first virtual machine with Linux operating system. I can have second virtual machines with Ubuntu operating system. I can have third virtual machines as Mac OS operating system. So on this Windows machine, you can have different virtual machines like your Linux, like your Ubuntu, like your macOS. And all these three different operating system, the different my VMs can run applications which are compatible with them. So if you have to run Linux related application, you can create virtual machine which will be having the operating system as Linux operating system, and on top of that virtual machines, you can now run your actual Linux application. So that is the overall picture of your virtual machine, correct? So your operating system, actual operating system will be there with your laptop itself. Like if it's the Windows operating system, it will remain there. But on top of that, when you have installed the hypervisor and when you have created the virtual machine, now this actual operating system which was there with your real system, the real laptop, it will be running all this hypervisor related process, all the virtual machines related process. But on top of that, your actual application will be running, and that virtual machine or that application will be utilizing the resources which are itself is virtual. That means that 8 GB of RAM, that 2 core of CPU, which is not the actual capacity of your laptop. That is just a virtual segregation of your actual resources which are available on your laptop. Correct. So your ultimately application will be utilizing those virtual hardwares, and your VMs will be utilizing the operating system which is installed on that virtual machines. Correct. But your operating actual operating system is also there with in picture, and it is running all the processes to keep these virtual machines up and live. Correct. So that's the kind of virtualization concept. So if you go with the terminology here, imagine you have one big computer, but you divide it into a smaller pretend computers. Each one thinks it is its own machine with its own CPU memory disk. These pretend computers or these extra computers what you install on top of your original one, that are called as virtual machines. Correct? All at the same time on the same physical laptop. So this is one physical laptop. On this physical laptop, you are going to create VM1, VM2, VM3, and all these VM can have either same operating system or different operating system as well. Now, what is the need of virtualization? You can run multiple operating system on one machine. The example what I'm covering every time. Correct. On Windows, you are going to run Linux. You are going to run Windows, Ubuntu. You are going to run Mac OS or whatever the operating system you want. It save hardware cost. On the same hardware, you have just segregated the hardware resources into four components, and you are utilizing for the different operating system. So that's the use case. What you can do, then you are going to test and develop different environments. Like you are going to run the Linux related environment, and you can test Linux application. You can run Mac OS related application that you can test. You can like run your application compatible with the different version of the Windows, correct? That you can test. So it gives you flexibility to create the different environments, and it also improve your server utilization in data centers, correct? Now moving forward, let's see in terms of picture how it will look like, and then we'll be moving forward, we'll be talking about the container as well. So these are the two pictures in terms of VM and in terms of your Docker container, correct? So your Docker container will be running through this Docker, correct? Like the second picture, if you see hardware infrastructure, on that top of that hardware, there is a operating system, then there is a Docker, and on this Docker, your different applications are running as a container, correct? So this is the concept of your Docker. But before that, we have talked about the virtual machine. So let's understand this one as well. There is a hardware infrastructure. On top of that, you are going to run this hypervisor, and on this hypervisor now you are going to run the different operating system. So this kind of hardware infrastructure can be having the Windows. On top of that, it's running Linux and Ubuntu. That kind of operating system will be there. Then the applications which will be running, they will be having their own library, the dependency, and ultimately they will run your application. Correct. Here in terms of Docker, on top of your operating system, on top of your hardware infrastructure, Docker will be installed, and this Docker will now ensure that container can run on top of this hardware itself, and they can utilize this host OS itself. They are not bringing the complete operating system to run their application, correct? It will just come up with the dependency, the libraries and everything, and it will be utilizing a base image. Like whenever you are going to run Python application, so you go with, like, if you have written a Docker file, you go with like Alpine image, correct? The lower one. Or if you are going to utilize the Java related, so you look for the some lightweight Java image, correct? So that kind of file that kind of command you write in your Docker file. So container uses the resources from your host OS itself, correct? and it run, like packages everything and it runs your application. While virtual machine will be having its own operating system, while container uses a guest operating system. That means the operating system which are already there on your present machine. So that's the difference between your Docker container and the virtualization concept as well, like virtual machines concept as well. What is Docker? Let's talk about this and then we will cover the other things in day 3. What is Docker? Docker is a containerization platform. It creates container, correct? And what is container and everything we'll be talking going forward. So it allow you to package application with all their dependency into a single unit called a container. So when we talk about the dependency, like you have to run your application and this application need to be run on Python 3.11, considering one version of the Python, correct? And if you have this if this system is having 3.9 version, 3.7 version of the Python, it won't allow you to run correct directly. So you will have to package everything as 3.11, the dependency, the version, each and everything, and that you can run anywhere, wherever you want. So it package application with all their dependency, that means source code related things, the dependency related things, each and everything. And that image can be deployed anywhere. It can be run as a container anywhere. It is lightweight, portable, and run consistently across environment. Like on any environment, you can deploy it and it can run. Real world analogy is that you are going to package anything inside. You are going to talk about all these things. Correct? The pointers we have already covered. Now we have to talk about VM versus Docker concept. What we have talked in the virtualization. Correct? What is the VM? What is the the Docker virtualization and the virtual machines, or like that those kind of virtualization. What you do through hypervisor. There are few pointers what we have highlighted here. Feature, OS overhead, virtual machine, full guest operating system, while Docker container just share the host operating system, correct? So just like the virtual machine, it does not come up with the full guest operating system. It just share the host operating system on which it is going to run, correct? So it's also called as lightweight. So as it's utilizing the host operating system, it will be lightweight because it does not have to carry the complete operating system, correct? So it is lightweight rather than this virtual machine. This virtual machine can take up to few minutes to start up, while Docker container does not have those much things to start up, so it can start on a faster pace. So it will be started in within seconds only, correct? Then hardware plus kernel, that virtual machine will be having the isolation level, kind of hardware plus kernel, everything will be separated. On Docker container, it's the kind of isolated process which runs on your system. Then they want on virtual machine it's OS level isolation, while on the Docker container it's application level isolation. You can say it just runs the process isolated, but it is going to utilize the same operating system. Correct? It will share that. If you talk about the portability on the virtual machine, it's limited. That means it cannot be sent here and there. Like it cannot be shared across too many platform. While the Docker container can be deployed anywhere, it can be run anywhere. So that kind of flexibility you do have with the help of Docker. So this is the use case. This is the feature of utilizing the Docker, correct? Now moving forward, we will be talking about key concept, the key Docker components and everything in day 3. And stay tuned to watch the other tutorials, to watch out the other Docker related videos which we will release soon. Till the time, thank you. Bye bye.